Very good morning to you. Today I'm gonna talk about a subject called flocculation. And we're gonna go through some points. Why am I talking about it? What is it? The steps of flocculation. And finally, how does the flocculation step affect the other treatment steps that comes after? So, let's start. And why do I want to talk about flocculation? Flocculation is probably the most used treatment steps in the water business. It's used in wastewater treatment plants, it's used in drinking water treatment plants, it's used in industrial process water cleaning. And probably a lot of you out there know that, but why do I want to talk about this subject? Because it's quite natural, you can find it in a lot of places. Well, I'm going to go through this because I've seen a lot of, how should I say, improvement potentials when I visited different types of plants, being industrial, drinking water, or wastewater plants. And even though it's a very common method, it's very old, it's used everywhere and has been tested and has been lots of literature written about flocculation, there are still in practical life lots of improvements you can do. Or if you find something wrong in a water treatment process, it's not uncommon that I've been able to trace it back to the flocculation step. So, from my perspective, I will try now to give you some of my, how should I say, experience in regard to what you need to think about when you work with flocculation. So, to the second point, what is flocculation? Basically, in the water you have particulate material, and it can be organic, it can be inorganic, but basically it is very, very fine particles most of the time that you want to remove before you continue the treatment process. And by adding a chemical flocculant, hence the word flocculation, you bind or glue these small particles together, so that these particles here will be glued together by the flocculant. And what do you think will happen? Well, of course, if you have a bigger floc, a bigger particle, it will sediment more rapidly. So you can remove it faster, and therefore you don't need as much time in the treatment process in order to remove the particles. And I talked about sedimentation, you can use it. Also, you can have a method called flotation, which lifts the flocks to the surface instead of to the bottom. And I will post some videos about flotation so you can have a look after this video. Now, I talk about particulate matter, but in wastewater treatment, you also have an additional effect. That is the removal of phosphorus in the water, a nutrient. So, phosphorus removal, you use iron in order to precipitate the phosphate in the wastewater. In other treatment processes, you also find very common also use of aluminium. And of course, both of those can precipitate phosphorus. So you have for the removal of particle matter, and if you need to remove phosphorus by precipitating the phosphorus with, most of the time, iron. So the process of flocculation is to remove particles, and in wastewater treatment, phosphorus. So now we come to maybe not the tricky part, but the key steps when you do the flocculation. And you have two steps that you need to go through in order to form these beautiful fluffy flocks that will immediately sedimentate, or the flotation unit will whip them up to the surface and you can remove them. Jokes away. Basically, you have one step called mixing, And you have, forgot the G there, you have the step where the small particles or the phosphate is precipitating, or the small particles is, how to say, clinging or gluing itself together with the chemical flocculants in order to form this nice flocks that sedimentates rapidly. So forming flocks. So 2 steps, first steps, second step. Okay? Now let's talk about the mixing step, which of course is the first step. So why do I call it a mixing step? Well, basically, now we're getting into the details. When you add the chemical flocculants, you add a very, very, very small volume. Now, can you guess what the volume of the chemical flocculant you add in, say, 1 cubic meter of water, 1,000 liters of water? It could be like 100, now I will be very careful, milliliter. So 100 milliliter, you add, that is 1/1000th of a liter, you add that in, yes, 1,000 liters of water. Now imagine this tiny portion of chemical flocculant. What does that need to do with the particles and the phosphorus? It needs to find them, right? So let's draw a schematic sketch of the adding of the flocculant. And let's just use an imaginary beaker, which you have 1 liter of water. And here you add a tiny, tiny, tiny portion. That is the flocculant, of course. So this tiny portion of flocculant, you now have to mix. And the mixing is to get all the particles in this volume in contact with this tiny volume of chemical flocculants. So you understand you need to really get this mixing going so this tiny volume can reach out in the big volume, hit the small particles, start the gluing or precipitating the phosphate. So that's the start of the quote-unquote mixing process here. So there is another issue also, and that's the density. But I've made a video about that, which I will post down below, and will show it here too. But basically, you have a high density flocculant, which also puts some, how should I say, focus on the mixing. But how can you then practically mix that tiny piece volume of flocculant in your volume? Well, the classical way, or well, I wouldn't say classical way, but one way is to use a mixer. And basically you have a motor and you have a propeller which mix really rapidly. So this small volume of flocculant is whipped in like, well, not like whipped cream, but a very intense mixing. The flocculant gets in the water volume, meets all the particles, all the phosphate if you're doing wastewater treatment, and bam, you have the flocculant homogeneously in your water volume that you want to treat. And here comes the question, how long with a rapid mixing do you need approximately to get this mixing done? Maybe, well, 10 to 20 seconds. But again, this depends on the water quality, how much particles you have, what the water temperature is, and so there are many parameters affecting the mixing time, so to speak, but it's all based on real thorough mixing. If you don't have that, you have a problem, because then you have the following step that won't work properly. So you have a mixer like the propeller. You also have what we call a static mixer. excuse my handwriting, it's not very good, but I hope you can read it. Static mixer, basically what you have as a static as opposed to a moving mixer. You have one way of doing it to have a static mixer is, let me see, I'm going to change the color. You have the pipe coming in, and here you basically place your static mixer, and in this section you have baffles. So when the water that you want to treat is coming in the pipe, it goes into the mixer. Then what do you think you do with the mixer? Here you add your flocculant, and in this section here you will have the start of the mixing of the flocculant and the water you want to treat. And if you design this correctly, now remember, a static mixer is designed for a certain flow, and depending on what type of water treatment you're working in, if you have very variant flow, you have to think on designing of the mixer. But that's a minor, or not a minor detail, but that's something you have to take with you if you use a static mixer. But if you do the design correctly, I would say maybe 0.5 meters after the mixer, you have the flocculant and the water you want to treat very good mixed. So we can go into the forming of the floc step. So propeller or static mixer, your choice depending on what type of water you want to treat, philosophies, water quality, so forth and so on. But the main thing is get the small portion of flocculant in the water volume that you want to treat, so you can get all the particles to glue together to get the phosphate to precipitate. Very important. Now, forming the flocs. Forming, it's not a very good pen, sorry. Forming the flocs. You have a mixed volume of flocculant and your water you want to treat. Now, when you form the flocs, a question to you, do you want a rapid mixing still, or do you want a very slow mixing? Well, it's kind of a rhetorical question, because now you've mixed it. Now remember, the flocs that are forming are very, very, how should I say, frail. And if you mix or have too big motion, you will destroy smaller or forming flocs. So when you go in to the flocculation chamber, this is a flocculation chamber. You have a mixer again, but this mixer is probably running at 10 to 20 revolutions per minute. So it's a very, very slow moving mixer. Very, very slow. There are other ways of doing the mixing, but this is the most common, not mixing, the flocculation, the forming of the flocs process. So very slow moving, and what happens then is you get a turning motion, and here you have flocs that are starting to form. So when you're in the flocculation chamber, the glue, the flocculant starts to hit small particles, adding to a bigger particle, and the bigger particle hits a small one and then hits another one, and you're building up the flocs. So in the end, you have really nice fluffy flocs that are easy to separate. But very importantly, slow mixing, and if it's too high, it will break the bigger flocs that has formed. So it's a very sensitive process. And again, the flocculation time, the flocculation chamber, can be everything from 5 to maybe 20 minutes. Now this is quote unquote a span of times, depending on temperature, water quality, particulate material, conductivity, lots of parameters. But normally I would say if it's very cold water, you go up to maybe 20-25 minutes to get a good flocculation. And all of this is based on having a good mixing, of course. Never forget that. So with that, we have now talked about the 2 steps of flocculation, and the mixing, the forming of the flocks are needed to be working as good as possible, because then after the steps of flocculation you can have, normally you have sedimentation, and after the sedimentation you have sand filtration. So let's look at sedimentation and sand filtration. What happens if you have a bad mixing of the chemical flocculant before the forming of the flock step? What happens if you have a bad formation of flocks when you go into the sedimentation? Basically, the particulate matter will not sediment as you wanted them to, because you have a poor flocculation process. So when it passes the sedimentation, you will have a high load of particulate matter that will go on to the sand filter, and that will load the sand filter, which in itself will make shorter cycle times for the sand filter. The clogging of the sand filter will increase. So this is a very important step of considering when you're looking at the flocculation step. So before I end, I just want to talk about the phase between the flocculation process and the following steps, what you need to be very careful with. And according to my experience, this is many times, well, I won't say many times, but often you can find a problem when the formed flocks is moving to, for instance, a sedimentation step after the flocculation. And let me draw a schematic again. You have the flocculation process. We'll mention FP, flocculation process. Now here you will now have some very, very beautiful flocks, because you've done everything correctly in the flocculation process. So here you're now going to transfer the flocks to the following treatment step, and that step comes here. It could be sedimentation, it could be flotation, but a question to you: can you pump from the flocculation step to the following treatment step? Well, I don't think so, because what happens in a pump basically will totally destroy all the formed flocks. This is not very common and very rare to see, but it's one of the basic things you need to always have in mind. You don't pump flocculated water, because that will completely destroy the flocks. Now, taking away the pump, we don't do that because we are very knowledgeable in flocculation right now. But something that will happen here is that when you, I will draw a new little sketch. From the flocculation chamber, you will have like this motion in the flocculation chamber. And one of the things you need to consider now is that the pipe or opening that the flocculated water will go through, the velocity in that pipe is so low that you don't get the flocks to break up again. And also you have this motion here that you need to stop in order to get the flocks over to the next step. So when you go on to a water production plant or a wastewater treatment plant, this step is a key factor that you don't mess up the flocks when you go to the next step. With that, I will herewith ended the lesson. And I hope you learned something, and I will be very happy to answer your questions if you have them. If you just post them, send them. And there are probably things you might see in the presentation that you think about. Just send me a question, I'll be happy to answer them. May take some time because there are other things in my life also except water, even if it's a big part. Now, enough about that. Take very good care and have a good day, evening, depending on when you're watching. Okay, cheers. Bye-bye.